Ricotta. Ricotta's name in Italian literally means cooked again because it is not traditionally made from whole milk at all. It is made from the whey left behind after producing other cheeses. That liquid, already largely depleted of casein, still contains a different class of proteins, albumin and globulin. When the whey is reheated to around 85 degrees Celsius, those proteins denature and precipitate out as soft white clouds that rise to the surface and are skimmed into molds to drain. The result is a cheese that is technically not a cheese in the traditional sense, since no rennet or significant acidification is involved. It is closer to a heat-coagulated protein foam. The flavor reflects this. Exceptionally mild, very slightly sweet, with a clean dairy freshness and a texture that is neither grainy nor smooth, but something loosely between the two. Romans were making ricotta in the 1st century CE, and it remains essentially unchanged. It is, in a very literal sense, a byproduct elevated into a primary ingredient. The Sicilian cannolo, one of the most recognizable pastries in the world, exists because someone decided not to throw away the leftover liquid from cheesemaking.
Mozzarella. Mozzarella belongs to a specialized subgroup of fresh cheese called pasta filata, stretched curd, which originated in southern Italy during the medieval period. After standard coagulation and cutting, the curd is heated in hot water or whey until it becomes elastic and pliable. It is then pulled, stretched, folded, and formed by hand. This repeated mechanical stretching aligns the casein protein chains into long parallel bundles, which is what gives mozzarella its characteristic layered, stringy pull when torn apart. The word mozzarella itself comes from the Italian verb mozzare, to cut off, referring to the motion cheesemakers use to pinch portions of the stretched curd into individual balls. Traditional mozzarella di bufala campana is made exclusively from the milk of water buffalo, a breed introduced to the Italian South between the 6th and 7th century CE, and it is legally protected by the European Union, meaning the name belongs to that geography and cannot be applied elsewhere. Buffalo milk contains roughly twice the fat of cow's milk and produces a mozzarella that is richer, creamier, and noticeably more complex, with a slight tang from the higher acidity of buffalo milk than its cow's milk counterpart. The low-moisture block mozzarella that covers most commercial pizza in the world is not simply an inferior version of the same thing, it is a fundamentally different product. The moisture is pressed out, the water activity is reduced, and the protein structure is modified specifically so the cheese melts evenly under heat, browns without burning, and does not release water onto the crust. These are valid engineering goals. They simply have nothing to do with what fresh mozzarella is for. Chèvre. Chèvre is the French term for goat, and it refers to a broad family of fresh and lightly ripened goat cheeses that have been made in France for at least 2,000 years. Goat milk differs from cow's milk at the molecular level. Its fat globules are smaller and more evenly distributed, its casein structure behaves slightly differently under acidification, and it contains a higher concentration of specific medium-chain fatty acids, most notably capric, caprylic, and caproic acid, which are directly responsible for the characteristic, sharp, bright, tangy quality that some describe as barnyard and others describe as clean and citrusy. Neither description is wrong. What you perceive depends entirely on the freshness of the milk and the ambient microflora of where it was produced. The most iconic shape in French chèvre tradition is the truncated pyramid of Valençay from the Loire Valley. According to legend, Napoleon Bonaparte, furious after a disastrous military campaign in Egypt, sliced the top off a full pyramid of the cheese with his sword when it was presented to him, and the shape stuck permanently. This story is almost certainly apocryphal, but it is the kind of story that persists because it is more interesting than the real explanation, which involves drainage molds and medieval ceramic-making traditions in the region. The ash coating on the exterior, charcoal gray and slightly dusty, is not decorative. It regulates the moisture loss during the brief ripening period and modulates the pH of the rind, creating an environment hospitable to the surface yeasts and molds that develop the light, bloomy exterior over a week or two. Brie and Camembert. Brie and Camembert are the apex of white mold ripened cheese, and the white rind on both of them is not decorative. It is alive.
The surface is intentionally inoculated with Penicillium camemberti, a mold species that colonizes the exterior and secretes proteolytic enzymes that break down proteins, inward toward the center of the wheel. Over 2 to 4 weeks, the interior transforms from a firm, chalky paste into a soft, near liquid core with a flavor that is buttery, mushroomy, and faintly earthy.
Brie de Meaux, the legally protected original, has been made in the Seine-et-Marne region of France since at least the 8th century. Charlemagne was reportedly served it at a monastery in 774 CE and became so devoted to it that he arranged for regular deliveries to his court. Camembert, made in Normandy, is younger. It was standardized in the late 18th century and differs from Brie primarily in size. Because Camembert wheels are smaller, the enzymatic activity from the exterior mold reaches the center faster and more completely, producing a more pronounced, pungent, ammonia-edged flavor in a properly ripe wheel. When a Camembert smells aggressively of ammonia, it is not going off. It is finishing. The relationship between the rind and the interior is one of the more elegant biological balancing acts in food production. The mold consumes lactic acid as it grows, raising the surface pH from around 4.6 toward neutral. That pH gradient draws the proteolytic activity inward. Cutting the wheel at the wrong moment, too early or too late in this process, produces either chalky and underdeveloped or collapsed and over-ammoniated results. There is a window of perhaps 4 or 5 days where a well-made Camembert is exactly what it should be. This is not a flaw in the design. It is a feature that rewards attention. Gruyere. Gruyere has been made in the canton of Fribourg in Switzerland since at least the 12th century, and its production methodology has changed remarkably little. Raw milk from cows grazing on Swiss alpine pastures is collected and processed in copper vats, a detail that is not aesthetically traditional but chemically significant. Copper has genuine antimicrobial properties that inhibit contaminating bacteria while allowing the specific thermophilic starter cultures used in alpine cheesemaking to dominate the fermentation. The curd is cut very fine, heated to around 57 degrees Celsius to expel moisture aggressively, and pressed into large wheels that age for a minimum of 5 months, with reserve grades reaching 14 months or more. The small, irregular holes in Gruyere, called eyes, are not formed by air trapped during pressing. They are formed by carbon dioxide released by Propionibacterium freudenreichii bacteria during aging. These bacteria consume lactic acid and produce propionic acid, acetic acid, and CO2. The CO2 accumulates in weak points in the protein matrix and creates the characteristic holes. The propionic acid is directly responsible for the nutty, slightly sweet flavor note that Gruyere is known for. The milk from cows feeding on high-altitude pastures contributes a further aromatic dimension. Alpine grasses contain terpenes and other volatile compounds that pass into the milk and survive into the aged cheese, giving it a faint floral, herbal background that is impossible to replicate with milk from cows fed on hay or silage indoors. Cheddar. Cheddar originated in the English village of Cheddar in Somerset, a place with dramatic limestone gorge caves that provided the cool, consistently humid environment historically used for aging. The technique that gives the cheese its name is unique in the world of hard cheese making. After the curd is cut and cooked, it is not immediately pressed. Instead, the blocks of curd are stacked and turned repeatedly over several hours, a process called cheddaring, during which the weight of the stacked curd expels whey mechanically, while bacterial acidification continues. The curd mats, knits together, and reaches a specific pH and texture before it is milled, salted, and pressed into wheels. The result of this extended acidification is a dense, smooth, close-textured paste with significantly lower moisture than most continental hard cheeses, and an acidity that drives the flavor development over aging. A 12-month cheddar is sharp and tangy. A 3-year cheddar can be ferociously pungent, almost spicy, with a crumbling, grainy texture. Those white crystals visible in aged cheddar are not salt. They are tyrosine, an amino acid that crystallizes out of the protein matrix as proteolysis continues over months and years. The larger, crunchier formations are usually calcium lactate. Both are the physical residue of chemistry happening slowly and invisibly. They are edible evidence of time. Roquefort. Roquefort is made exclusively from the raw milk of Lacone sheep and aged exclusively in the natural limestone caves of Cambalou near the village of Roquefort-sur-Soulzon in southern France. It is the oldest named cheese in recorded European history, mentioned in Roman writings as early as 79 CE, and one of the most legally protected food products on Earth. Nothing called Roquefort can exist anywhere else.
The blue mold in Roquefort is Penicillium roqueforti, a species native specifically to the Cambalou cave system. After the wheels are formed and salted, they are pierced with thick metal needles to create channels throughout the interior. Mold requires oxygen to grow, and without those pathways, it cannot penetrate the dense paste. Once the oxygen channels are open, the mold colonizes from inside outward over roughly 5 months of cave aging, producing the characteristic blue-green veins that run through the ivory paste and a flavor that is sharp, salty, deeply savory, and tinged with an almost metallic edge that comes from the particular volatile compounds, specifically methyl ketones, that Penicillium roqueforti produces as it metabolizes the fat in the cheese. There is no reproducing this flavor in another location, because the Penicillium roqueforti living in the Cambalou caves is not the same microbiological entity as the same species grown in a laboratory. It is co-evolved with the specific temperature, humidity, and airflow patterns of those caves over centuries. The cave is not a setting. The cave is an ingredient.
Parmigiano Reggiano. Parmigiano Reggiano is made within a precisely defined geographic zone in northern Italy, the provinces of Parma, Reggio Emilia, Modena, and parts of Bologna and Mantua. The milk must come from cows fed exclusively on local forage and hay. Silage, fermented feed, is prohibited entirely because the Clostridia bacteria it introduces would cause late blowing defects during aging, where gas pockets form inside the wheel and destroy its structure. This feed restriction is not tradition for tradition's sake. It is a technical requirement that every element of the production chain enforces.
The wheels weigh between 30 and 40 kilograms and must age a minimum of 12 months, with Stravecchio grades aged 24 months and Reserva aged 36. Some exceptional wheels are held for 72 months or more. Roughly 3 million wheels are produced annually, each requiring approximately 550 liters of milk. Before a wheel can carry the name, it is examined by a consortium inspector who taps the exterior with a small percussion hammer and listens for internal defects, hollow sounds indicating cracking or gas pockets. Wheels that pass are fire-branded and laser-etched with identifying information. Wheels that fail are marked with cuts across the rind so they cannot be passed off as genuine. At 36 months, the flavor is intensely savory, almost aggressively umami, because long aging has broken large quantities of protein down into free glutamates, the same compounds responsible for the deep satisfaction of tomatoes, mushrooms, and cured meat. The crystalline texture is tyrosine accumulation. The faint background sweetness is residual lactose concentrated by moisture loss and interacting with fat over years. Every flavor in a properly aged Parmigiano is a named chemical event. It is the most legible cheese in existence, if you know how to read it.